This is a flipped video for writing the equation of a parabola. So we're going to start this lesson with an example. Notice on the left side of the page we have our equation for a parabola in intercept form, and on the right we have a graph which we are going to use to plot important points to help us find the equation for this parabola. So the first thing I want to do is find my P and my Q values, and those are determined by our x-intercepts. So we look here, our x-intercepts cross the x-axis, so it's these 2 points, and they are located at 0, 0, and -2, 0. The next step is to identify a third point that we can then use to plug into our x and our y of our equation. So one point I noticed right away is my minimum, or my vertex here, is located at -1, -1. I'm going to use this point, but other points that I could have used, or you could have chosen to use, could be this one here, which is 1, 3, or another easily identified point is located here at -3, 3. So my first step is going to be then to plug in my P and my Q values into my equation. So when I do this, I get y is equal to a times x minus p, or -2. And so switching the sign, I get +2. And then x minus 0, which is just x. My next step is to then use my point that I chose, which was my vertex here, and plug that in for my x and my y. So plugging that in, I get -1 for y is equal to a multiplied by -1 for my x plus 2 times -1. So my next step then is to simplify and solve for my a value. Doing this, I get -1 is equal to a times -1 plus 2, which is +1, sorry, and -1. And this gives me -1 is equal to -a. Since both sides are negative, I divide both sides by -1, and that gives me a is equal to +1. So now I have all of the tools I need to represent my equation in terms of my x and my y values. So what I do now is I rewrite my equation, plugging in my P, my Q, and my A values that I found. So when I do this, I get y is equal to 1 for A, but since it is 1, I don't have to write it, multiplied by x minus P, or minus a -2, that gives me +2, and x minus 0, which is x. And this is the final form for our equation in intercept form. So let's go over our steps. The first thing we did was we substituted in our x-intercepts for P and Q. The next thing we did was we chose a third point that was easily identified and substituted that in place of our x and our y values. We then used these 3 points to calculate our a, and then finally we rewrote it in intercept form by substituting in our p, q, and our a values. Now the final step listed below says to distribute to find the equation of the parabola. We are interested in doing this when we want to write our equation in standard form. So this specifically is for being written in standard form. Now we are not going to write any of our equations that we work on today in standard form, but this is something that you will want to do for future lessons. So let's look at a second example. Notice on this example we have our x-intercepts located at -3, 0, and 1, 0. So what we want to do is we want to plug in our two intercepts in place of our P and Q, and that gives us y is equal to a multiplied by x minus a -3 or plus 3 and x minus 1. Our next step is to choose a third point, and this graph gives us a point that we can use located at -1, 2. So our y value is 2 and our x value is -1. So a multiplied by -1 plus 3 times -1, -1. So then we simplify and we solve for our a value, and this gives us 2a is equal to, or times 2 times -2. And that is equal to 2 is equal to -4a. So solving for a, we divide both sides by -4, and that gives us -1/2 is equal to a. So we have now found our a value. So our final step then is to plug in our p, q, and our a to get our equation in intercept form. So y is equal to our found -1/2 a. Oops, no a. -1/2 is our a. And then write it in terms of our x value, so that gives us x plus 3 for our p and x minus 1. So notice that our graph is opening down. Our a value here was a -1/2. So this is a pretty good sign that you set it up correctly if you're ending up with a graph that is opening down and then your a value is negative. So look at a final example. We have the graph here, and our x-intercept is located only at a single point. Since our parabola only crosses the x-axis at a single point, that means that our p and q both have to be the same value. So when we do that, we know that our p must then equal 2. But by default, so must also our q. So when I plug that in, I plug in y is equal to a times x minus p, which is 2, and x minus q, which is also 2. So we have a double root since they're both located at the same point. Now our next step is to pick a second point, which it gives us at 0, 4. So our y value is 4, is equal to a, which we don't know yet, and our x value is 0 minus 2 times 0 minus 2. This gives us 4 is equal to 4a. So -2 times -2 is positive 4. Next step is to solve for our a values. We divide both sides by 4, and this gives us a is equal to 1. So finally we plug this back into our original equation, and that gives us y is equal to, a is equal to 1, so we'll just leave it, x minus 2, x minus 2, or if we wanted, we could also write it as x minus 2 squared. So in review, our steps are: we write the equation of a parabola in vertex form, we substitute the intercepts for p and q, so we identify those on our graph, then we pick a third point and we plug them in for x and y, and then we use these 3 points to calculate our a. Lastly, we rewrite in intercept form by plugging in our p, q, and our a values. And as a final point, if we want to get our equation into standard form, we distribute our factor groups to find the equation of the parabola.